My blockheads have gone on strike. They refuse to move stones on primitive sledges. They say it's a drag. So I've designed a new gizmo for them in the hope that they can get on with it. Damn unions. We have some requirements. Easy preparation for transport, easy pickup and drop-off, and least unnecessary friction. We have most of this with the sledge, but it's frictionally challenged. Here's the new design. It's just a lever mounted on an axle with two wheels. The wheels are 8 to 10 feet in diameter, and the axle is thick enough to support about 3 tons. It works by hooking the rope loops from the rock onto the notch on the lever. Then it's raised by pulling down the lever. The weight of the lever should act as a counterweight to the rock, so the stone must be as close as possible to the axle. Because the lever itself is fairly heavy, you need a stick or pole to push it up. Then hook up the rock. Then you need a rope to pull it down, thus raising the stone a few inches above the ground. Because the wheels are so large and wide, this machine can traverse sand and rubble from the quarry all the way to the pyramid with little trouble, as compared to a sledge. I think 8 men could handle it on level ground. Where the incline is too great, a team of extra men would attach a rope to their wagon and assist till they reach the top of the incline. Then they detach and go back to help the next team. When they get to the pyramid, the blocks can be lined up in rows, so they are ready for the summer crew. If each team takes 10 blocks of the pyramid per 10-hour day, and they work 300 days per year, that's 3,000 blocks per year per team. If they take 8 years to complete the pyramid, that's 24,000 blocks per team. So we need about 100 teams, continuously operating for 8 years, to deal with 2.5 million stones. These wagons would be required to travel about 10,000 miles total. I don't think they'd take that much punishment, so the carpenters would be constantly making new wagons as they wore out. But they don't need any wood for sledges or sledge tracks. When a stone is brought to the dumbwaiter on the side of the pyramid, it can be simply placed there naked. It goes up as before, by being pulled up by 200 men. I think the dumbwaiter should be inlaid with rocks, because the blocks would wear out the wood too fast, and they slide off better also. At the top, a rope sling would be thrown over the rock, and it would be pulled along the rock surface at that level of the pyramid. I'm not sure this would beat the sledge technique. You could use a wagon up here too, but turning around is a problem. I think 8 to 12 guys could pull it across the pyramid to the opposite side, but I'll be damned if I'll do it. There is also a problem with the spaces between the blocks you're walking on. Are they filled in? I don't know what the Egyptians did. If we inserted an optical probe into the interstices of the pyramids, maybe we could find out. I suppose that this has already been done, but I have found no information. Maybe they filled in the cracks with rocks and sand. A little sand and pebbles would make the rocks slide better when you pulled them over the level you're working on, like a car sliding out on a curved dirt road. It would also help to have somebody use the big monkey wrench to take the weight off the front of the stones so it doesn't get hung up on the high points along the way. When the stone gets near its final resting place, it may be just pushed into place with a bang pole by maybe 10 guys. Wham! There's another problem of finishing the level. The corner-facing stones have to be laid first, and then the other facing stones will be easy, except for the last stone on each side, which will not fit, and will have to be dressed on site, or mortar will have to fill if it's too short. And the last stones of any level have to be dropped into the remaining holes. This requires some way of lowering them into place without ropes, because you can't get the ropes out after the stone is set down. Some sort of tongs are needed. I've designed one here. Maybe it won't work well, but there are many other designs possible. The trick is to grab the rock near the top, and when it's 2/3 or more into the hole, it lets loose and drops the rest of the way into place. So we'll need at least one big wagon lever on top to act as a crane. We pick up the rock with the tongs, move it into position over the hole, then lower it with ropes that go around a wood piece a few times. The friction of the rope on the wood allows one man to hold the stone from falling. Then he releases his hold a bit, and the rock, held by the tongs, lowers into the hole until the tongs contact the surrounding rocks, and the object stone falls the rest of the way with a resounding, level finishing thud. The next level of the pyramid would be started before the last one is finished. Nobody will wait around if they can continue from another point, so the pyramid might go up something like this. The Khufu pyramid sits on top of a rock outcropping. The purpose of this is to anchor the structure to the bedrock. Unfortunately, they didn't anchor the facing stones. To do this, they would have had to dig a shallow trench around the perimeter and start placing the Tura facing stones from slightly below the surface of the bedrock. And some holes would have to be dug randomly to start the rough stones as well, to anchor them to the bedrock. Leveling would have to be done by using different thicknesses of blocks on the first layer. The way the Egyptians did it is uncool from an engineering perspective. The facing stones all fell out and down, except for a few on Khafre's pyramid, and the few left at the top are held in place by the extra pressure of the lower ones angling to drop. Their leveraged pressure held those above a little tighter, enough to keep them in place till the earthquake subsided. Nobody has tried to dislodge these because it's way too dangerous. It's an avalanche waiting to happen. Why, oh why, didn't the ancient Egyptians have the foresight to anticipate my hindsight? Go figure. I don't necessarily think that the Egyptians used big honkin' wheels, but they could have. The point is that I think the Egyptians had a lot more smarts than the Egyptologists give them credit for, though I doubt that they were as smart as me. Just think about it. They made this. And a 480-foot tall, perfect, smooth-sided, brilliant white pyramid with a gold tooth on the top. But they couldn't make a wheel. Wow.